very good day. This is my video presentation for final year project entitled Prediction of Fire Emission of the Fabrics in Living Room of Malaysian Context. So basically, this my presentation outline. It comprises of the introduction, problem statement and the objective, and then the methodology, and the fourth one is the result and discussion, and last but not least the conclusion and recommendation for this project. Okay, we come to the introduction of this project. So based on the annual report from Fire Rescue Department, fire in residential house has been always on top of the list in the reported cases. So in 2018, there's around 6,000 cases have been reported in Malaysia, and along that number, we have 120 to 150 people die in the case. So we got the trend there where the trend is going to be similar along the years, and maybe it is expected to be the same for the next years or for the future. So there are many aspects actually that can be discussed. However, in this study, we are focusing on the emission of the common material used in the house of Malaysia, because there are too many flammable things that we use in the house that may lead to the fire. So since that we have heard that the house fire is rising, and most of the cases are due to the flammability of the material itself, then I think that this project need to be addressed. So the most problem that should be encountered is the selection of the material that being used in the house, because in Malaysia there are lack of data for many modern materials that being used. And so regardless of those issues, the project will evaluate the time emission of the common things that being used in the house, and to predict the time emission for the other materials that might be used in future.
Hence, the experimental work is conducted based on this methodology. So it have 3 phases of this project, which comprise phase 1, investigation of the time emission of the common house fabrics. Phase 2, the investigation of the trend line of the heat flux of the candle. Phase 3, the mathematical modeling, where to predict the time emission for the material that being used in the house. So in phase 1, the time emission of the material is evaluated. So the experimental is conducted under the chimney chamber and in the control environmental. So the experimental will be as attached here in the figure. So the time emission are taken at different height, where there are 5 cm, 6.25 cm, 7.5 cm, and 10 cm. So in phase 2, the investigation of the trend line is using the heat data logger. So this heat data logger will measure the temperature of the candle flame. So this is done in order to check the heat flux released by the candle, because there are limitation in this project work. The UPM does not have any flux meter or cone calorimeter, or maybe ISO ignitability in order to check or measure the heat flux. So the alternative of that limitation is by using this heat data logger. And then the phase 3 is conducted after all the lab work is finished. So this phase is the mathematical modeling, where it is inputted to be a simulation Excel in order to calculate the prediction of the time emission. So the model used here is the flux time product model, where it needs it have to be comprised with the heat flux and the critical heat flux of each material. So as the result and the discussion will be discussed after this, the result and discussion will be on statistical analysis. So for the result and discussion for the phase 1, basically there are two type of the initial behavior for this experiment. There are two, which are charring and melting. So for charring, the behavior is once it is sparked, it will ignite and combust with the char formation. However, for the melting, it will be disintegrated and shrinking and fall off without char formation. So as I mentioned before, the sample that I have used is cotton and polyester. So for cotton, the ignition behavior is charring, but for polyester, the ignition behavior is melting. So both are the different ignition behavior. After conducted around 300 samples for polyester and cotton, so I found out that the ignition time for the material are not constant, even it is at the same condition and parameter. So we can see from here, the histogram here, the ignition time is varies among the 5 cm, 6.25 cm and 7.5 cm. This means the diffusion ignition time for each sample is not the same. So as you can see, here, the polyester here, there are vast majority of ignition fall under 2.6 to 5 seconds. However, it still got some sample that burn at 10.1 and to 12.5 centimeter. So there are difference here, even it is at the same height. So for example, for the cotton, we have a 7.5 centimeter here. It is distributed centered around. There are no vast majority in this area. So it also have the outliers here to the right. So the outliers may happen due to the shortage of the trial that I've done during the experimental work. So based on these results, I can say that the uncertainty may due to the environment factor and the condition of the flame itself. So I can say that the condition of the flame is turbulent. Since the flame candle is turbulent, therefore the heat flux may be fluctuating during the experiment. Then with that, I'll check the heat flux using the heat data logger. So it come to the phase 2. So the trend line that I have gained here is fluctuating, but I managed to get the shape ratio of the heat flux after a long time of experiment. So this conclude that the heat flux released by the flame is not stable. We can see the shape ratio here, and it is fluctuating along the time. So this caused the emission of the material of each trial will be not the same. With that, after the heat flux is getting here, so the prediction of the time emission is done by simulation of mathematical modeling. So in flux time product model, I need to use the heat flux and the critical heat flux itself. So based on the heat flux ratio generated here in the previous work, I managed to complete it in the mathematical modeling. Therefore, I got the prediction time for this particular fabrics for the cotton, polyester, nylon, polypropylene, acrylic, olefin, polycotton, and polyfin. So the trend seems linearly to the different of height. This is because the candles heat flux release exposed to the sample is not the same. So the prediction outcome is being ranked for the from the fastest to the slowest ignition. So the ranking would be the first rank would gain by the polypropylene, which means the polypropylene have the fastest ignition compared to the others. And the second is polythene, olefin, polyester, polycotton, acrylic, nylon, and cotton.
So, for the conclusion, it was found that the candle's flame is turbulent and it resulted to the various value of the heat flux released by the candle. So, this condition actually really picture the real case of fire in reality. And number two is the emission time of the fabrics depends on its flux time product and the critical heat flux for each material. Therefore, the selection of the materials can be made where from this research, cotton is the safest material to be used in the house since it have longer emission time. So for the recommendation for this project, actually we must evaluate more type of the fabric instead of doing for cotton and polyester. And number two is for the proper measurement of the heat flux, we need to use a proper instrument such as ISO ignitability, concalorimeter, or maybe heat flux meter. So that's all from me, and that's all for this project.